A constant challenge for database designers is to design systems that are maintainable, scalable, and perform well. And it sounds like that's very obvious, that's always what we want to achieve, but it's often quite difficult. And what usually happens is that we have to make this choice. Is it going to be maintainable or scalable? And often we have to make this choice. Maintainability and scalability might suffer in order for us to get an acceptable level of performance. So a technique that's used to try to achieve a balance between these things is called partitioning. And while that concept is not new, it changed significantly in SQL Server 2005 and continues to evolve in SQL Server 2012. The database system provides tools to help developers achieve this challenging task. So why would we go to the trouble to partition? Partitioning will divide large amounts of data into smaller, more manageable subsets. You might ask yourself, how does this relate to database tables and performance? Well, modifying and searching smaller, well-organized sets of data is certainly easier and faster than working with a really large set of data. For example, if we were looking for an invoice for a particular date, it's far more efficient when you're looking at an organized filing cabinet. The same holds true for large database tables. Generally speaking, partitioning can improve manageability and scalability of large tables when the following conditions are true. The table currently holds or will hold a large amount of data. There are varying access patterns. For example, sales data for a current quarter might be read-write, while the previous quarters are read-only. Queries involving the table do not perform as expected. They might be running a little slow. And maybe the maintenance on that table takes too long or exceeds your available maintenance windows. Examples of this are reindexing or backup operations. But when you implement them properly, partition tables and indexes will benefit from the following: faster and more efficient data access. As I said earlier, smaller sets of data are easier to work with than large ones. Performance will increase because there will be parallel operations on multiprocessor servers, which is basically the norm. Processors can access multiple partitions simultaneously. And maintenance tasks, such as backups, are far more efficient as they can focus on specific partitions. Here's a note, though. Table and index partitioning is only available in the Enterprise, Developer, and Evaluation editions of SQL Server 2012. So let's talk a little bit about partitioning in SQL Server. SQL Server 2012 provides tools necessary to easily create and maintain partition tables and indexes. Tables and indexes directly support partitioning due to the way that they're architected. And while the concept is not new, earlier versions of SQL Server really put the burden of partitioning, creating and maintaining those partitions on you, the developer. So let's take a quick review and compare techniques for various versions of SQL Server. In SQL Server 6.5 and earlier, it was brute force. You had to design and implement everything. The developer had the sole responsibility. Individual tables were used to represent a segment or range of data, and they were brought together logically by views. Let's take an example. Consider having 4 tables, each representing a quarter's worth of sales data that physically hold the data. We'd have to use a union view to bring the data together logically to represent an entire year's worth of sales. And the way that we usually controlled access to the tables was through stored procedures, and that added complexity to the process. Insert, update, and delete operations needed to have a stored procedure to determine which of the 4 base tables the data modification should occur. And finally, when we were using a union view, SQL needed to look at all of the individual base tables in order to retrieve the data. And because of that, there was little to no performance gain. Things progressed a little bit in SQL 7. There was some slight improvements made. We still needed individual tables, but SQL actually evaluated constraints on base tables to remove them from consideration when processing. This is known as partition elimination. Each of the base tables had a check constraint put in place, and that defined the range of data that was suitable for that table. SQL Server takes into account those constraints and eliminates partitions not required for a particular query. So let's take an example. Here we're going to select all the rows from the annual sales where the order date is between July 23rd and July 27th of 2005. That is our query. We're going to look at our entire set of data to do that. Underneath, we have 4 tables representing each individual quarter. And what happens is SQL would go through the partition view over here on the right, where it would go through and do the selections. So we would select all the rows from Q1, union that with Q2, Q3, Q4. Now, because of the elimination, what's going to happen is we're going to be able to remove Q1, Q2, and Q4 from consideration. Based on that where clause, SQL will now be able to do that and retrieve the data more efficiently. So while performance improved for data selection, SQL 7 didn't make any enhancements for DML operations like insert, update, and delete. They still required working with underlying base tables. Direct modifications through those views were not possible. SQL Server 2000, we're getting a little bit closer to our ideal. SQL Server 2000 allowed data modifications to take place on those partition views, and when you executed an insert, update, or delete against that view, SQL automatically applied the statement to the proper underlying tables. And this enhancement delivered a consistent level of abstraction because it allowed selections and modifications to occur through those partition views. But SQL Server still required you to implement and maintain those base tables. With SQL Server 2005 and 2008, performance gains and simplified administration were part of the package. They combined the benefits realized in previous releases, and extensions were added to T-SQL to provide easier administration of partition tables and indexes. SQL Server actually creates and maintains the individual base tables, so implementing those logical views was no longer required. And the way that it achieved this was that there were actual changes to the way in which tables and indexes were constructed. Tables and indexes actually consist of one or more partitions. And by default, a table or index that consists of a single partition residing on a single file group was equivalent to tables and indexes in prior releases. So starting with SQL Server 2005, tables and indexes actually consist of one or more partitions. So let's take a look at this graphic. Up here we have our annual sales table, and it contains all the data that reside on one or more physical partitions underneath. SQL Server is going to maintain those partitions for us and allow us to gain access to the entire table and see it as a logical table, which is exactly what we wanted. So now with the basic structure of tables and indexes using partitions, there are specific T-SQL commands available for creating and maintaining those partitions. And those commands perform the following operations. We can define and create partitions, we can map partitions to physical locations on disk, and we can manage those partitions by splitting or merging existing partitions in the future. And there are functions available for us to get at the metadata and query partition information. So what's new in SQL 2012? Well, it now supports up to 15,000 partitions by default. And although that may not sound like a big deal, prior releases only supported 1,000 partitions. And if you were going to try to, for example, organize your sales data by day, well, now we have a limitation. And with 15,000 partitions now the default, that limitation is disappearing. But one important thing for you to remember, if you install SQL Server on a 32-bit platform, it does allow for more than 1,000 partitions on a table or index. but it's not supported by Microsoft, so be careful. In addition, statistics are now generated by looking at a subset of rows within a partition and not by scanning all rows. And finally, there were some enhancements made to the Manage Partition wizard, allowing you to switch in and switch out partitions. So let's begin the conversation about partitions. A range partition is one that divides a table into logical subsets based on a range of values. Boundaries define the limits and can be modified in the future. Some of the more common ones are date-based ranges, such as the order date in a sales table. The order date values determine which partition the sales data actually belongs to. SQL Server works quickly and easily with range partitions. Boundaries define exact data ranges, allowing SQL Server to determine the precise partition or partitions that are required to process a given task. Some of the important steps for creating range partitions are the following. First, we have to define those boundaries. This is known as the partitioning function. Then we have to map those partitions to one or more file groups, the physical layout of those partitions, and that's known as the partitioning scheme. Then we have to create tables and indexes that actually use that scheme. Some things to consider when you're planning to partition a table are: does the data lend itself to logical grouping or take advantage of partitioning? Which column actually provides the best value for partitioning that table? And what range of column values actually defines each partition? The column that provides the partitioning values is called the partition key. It's a column that logically groups the data into ranges, such as discrete integer or date values. Some considerations to think about when you're selecting a partition key are: there are some unsupported data types, such as the timestamp, image, XML, varchars. Be aware of those. In addition, any column whose data type is a Microsoft.NET Framework CLR user-defined data type is invalid. You can't use a column with an alias data type. And if you use a computed column, mark it as persisted because it actually has to store the data. After you select a partition key, the next step is to decide how to divide the data into ranges. Each distinct range will define a partition, and all the partition key values must map to a partition. The maximum number of partitions is now 15,000. And you want to define partitions based on data access patterns or logical groupings, such as sales order dates or zip codes. The actual number of partitions really depends almost entirely on the data access patterns and logical groups that you think will work best. The key thing to remember is to choose what makes sense initially. You can always modify the scheme in the future. So let's talk about file groups. SQL Server database objects are stored on logical entities called file groups. Individual file groups will consist of one or more physical disk files. SQL Server supports two types of file groups. The primary file group. All databases contain a primary file group, and that's where, at minimum, system objects are stored. And then there are user-defined file groups. And those are identified through the create database or alter database statements. If no user-defined file groups exist in the database, or a user-defined file group is not marked as the default, then all objects that are created will fall into the primary file group. Here's a tip. To reduce the access contention and gain a little performance, you should always try to do the following. Create a user-defined file group before creating any other database objects. Mark that user-defined file group as the default. SQL Server will create database objects on a default file group unless it's instructed otherwise. SQL Server will access system objects located on the primary file group more efficiently now, as there is no contention for accessing the other database objects. Things you want to remember when deciding initial file group layout. File groups map to one or more physical OS files, and using multiple file groups will reduce the access contention to database objects. Some database tasks, such as backing up, can actually occur at the file group level, so this will improve performance. And file groups mapped to multiple OS files on separate disks perform better. So, when you're considering partition tables, keep these points in mind. Partitions exist on file groups. File groups can actually hold one or more partitions, and creating one file group for each partition actually will provide the greatest flexibility in the long run. The following is generally true when deciding a file group layout. Multiple file groups provide better organization and increased performance. If you keep a one-to-one relationship between file groups and partitions, it gives you flexibility and increased performance in the long run. Here's an example of one of the many possible partition file group combinations supported in SQL Server. You can see here at the top we have our sales table, which is our single table that consists of 1 to n partitions. Those 1 to n partitions exist on 1 to n file groups. Again, this is still logical at this point. And those logical file groups are then mapped to physical OS files. And in the case here, we're just representing that file group 1 and file group 2 might map to multiple physical OS files, where file group n is mapped in a one-to-one relationship. Again, just an example, but something for you to use as a guide. SQL Server 2012 not only supports partitioning of tables, but indexes as well. When you partition an index, they can exist independently of the base table, but if you implement them with the partition table, you'll often get better performance. New to SQL 2012 is the fact that statistics are no longer created by looking at all the rows, but rather by using a default sampling algorithm, and you can use the update statistics with the full scan clause if you have to look at all rows. Indexes and tables that are partitioned and use the same partitioning function and partition key are in what's known as alignment. And when table and partition indexes also use the same partition scheme, they are called storage aligned. When they're aligned, the division and storage of the data is identical, and that allows SQL Server to access the data more efficiently. SQL Server will automatically align a newly created index with its partition table unless you specifically state otherwise in the create index statement. And while it's possible to partition an index and not align it with its table, keeping them aligned will get you better query performance. So here are some key terms to keep in mind. Like I said, alignment. When an index and a table are aligned, they use the same partition function and partition key. And storage alignment means that not only do they use the same partition function and partition key, they use the same partition scheme.